Welcome back to another session of Chapter 1 Real Numbers of Class 10 Mathematics. In this session, the last question of exercise 1.1 will be discussed, and it is also an application of Euclid's division lemma. So let us move on to the last question of exercise 1.1, question number 5. The question is, use Euclid's division lemma to show that the cube of any positive integer is of the form nan m plus 1 or nan plus 8. So we know that we did in the last questions. We will start with Euclid's division lemma. Euclid's division lemma states that for any positive integers a and b, there exist positive integers q and r such that a is equal to bq plus r where 0 less than or equal to r less than b. So we did few problems based on this one. Now here we'll start with let a be any positive integer as before. Let a be any positive integer. Positive integer. Okay. Now we need to take a value for q. So normally we were looking at the question, and we'll check which number is coming here. So here you can see it is 9, but it is cube of any number. We need to find the cube after stating the Euclid's division lemma. So it is enough to take b is equal to 3 also, because when you find the cube of 3, you'll get 27. From there you can take numbers out 9 common and you will get it. The problem when you are taking b equals 9 is then the value of r will be 0 less than or equal to r less than 9, which means r value will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and the problem will be very big. But if you're taking b equals 3, the value of r will be 0, 1, 2, and we'll get the answer also. So we'll take b equals 3. b equals 3. Let b equals 3. Then using Euclid's division lemma, we can write it as a equals 3q plus r where 0 less than or equal to r less than 3. The value of r can be 0 or 1 or 2. These are the three possibilities. So we'll take first r equals 0. We'll start with r equals 0. So when r is equal to 0, a will be equal to 3q plus 0, that is 3q. And we need to find the cube of any positive integer. So we need to find the cube. So a cube is equal to 3q the whole cube, which means 3 cube is 27. So this will be 27q cube. So we need a nan format. So what we'll do here, we'll take a nan common. So nan outside. So this will be 3 times q cube, and it can be written as nan m where m is equal to 3q cube. Okay, so we got it, nan m. It can be one form, will be nan m. Now we'll go for the next. R equals, if r equals 1, then the statement will become a equals 3q plus 1. Now we need to find the cube of a. So a cube is equal to 3q plus 1 the whole cube. So we need to apply a plus b the whole cube. What is a plus b the whole cube? So a plus b the whole cube you already learned. It equals a cube plus 3ab times a plus b cube. So this is the identity you learned in class 9. So using that we'll get this is equal to a cube. A cube, it is 27 q cube plus 3 times a times b. So 3 times a is 3 times 3q. So that is 9q times a plus b. 3q plus 1, 3q plus 1 plus b cube. Here b is equal to 1, so it is 1. Now we'll, from the first two terms, we can take 9 outside. So we'll take 9 outside. So it will be 3q cube plus q times 3q plus 1 plus 1. So you can take the complete this bracket term as m, so that we'll get it equals 9m plus 1, where m equals 3q cube plus q times 3q plus 1. Now the last case, that r equals 2. When r equals 2, so the Euclid's division lemma, the statement will be a equals 3q plus 2. Now we'll find the cube of a. A cube equals 3q plus 2 the whole cube. We'll expand using a plus b the whole cube formula. So you'll get a cube, that means the first term, the cube of the first term, that is 27q cube plus 3 times the first term and the second term. So 3 times 3q is 9q times 2 is 18q times a plus b, that is 3q plus 2 plus the cube of the last term, 2 cube is 8. Now here also we'll take 9 outside common from the first two terms. So you will get 9 times 3q cube plus 2 times q times 3q plus 2 plus 8. And here, if all the bracket terms is taken as m, is an integer, right? You can take it as 9m plus 8, where m equals 3q cube plus 2q times 3q plus 2. So you will get the cube of any positive integer will be either of the form 9m or 9m plus 1 or 9m plus 8. Now it is the time for the homework. The homework question, only one question. Please try. And that's all for today. Thank you. Bye.